which we have built in-house. This model is basically identifies application fraud and early claim at the time of login. So basically, this model we have developed for all the savings logins cases. So the need for developing this model is basically come from we have a very lesser claim settlement ratio in the previous financial year. So in the previous financial year, we have kind of starting this model. That was the early point for this. So we have seen that a lot of early claims are coming from all the cases where we do the minimal intervention in terms of like we do not do medical and financial check. That is because of I mean savings is a portfolio where customer mainly go for the investment purpose, and it is not feasible for us to do 100% medicals on all the cases. So we have seen that the cases which are going through straight through process, there were a lot of early claims were coming. So it is not the case like there was no risk triggers in the past. There were risk triggers like business rule engine rules, negative pin code, bearing of onboarding a policy. There was IIB information which comes from Insurance Information Bureau, and then there is a one more model litmus which kind of triggers the risk. And we have find out in our study that these risk triggers are not capturing all the potential claims cases. So we have kind of taken the whole data, and we have developed this new model, which is propensity to longevity and risk. So basically, we have taken all the demographics data and product related data which impacts mortality, and we basically kind of use the variable selection, and we have find out what are the variables which are actually making the difference and helping in predicting the risk and fraud. Uh, we have used various algorithms, but we have find out that the gradient boosting algorithm works best, and we have kind of used that and go ahead. This PTLR model is a combination of two models, so it is not a single model. There are basically propensity to early claim, which basically predicts if the customer will file a claim within 3 years. There are two models, savings non-linked and linked, because these products are very much different in terms of nature, how they work in the real life. So there is a need to build two models, and then there is a model which basically predicts if the customer is trying to do a application fraud. Then we combine these two models into one, and further we overlay lot of other information to reach reach to the final population, which basically on which basically we are doing the interventions. And once this model is in the place, we have replaced all other triggers because this model was performing very good in our back testing of the data. So basically, what was our line of thought that all the models which we have built. So for example, early claim model and the risk model, which I'm talking about, is giving me the probability, and probability we are basically doing the in the five categories basis the probability ranges. So the more higher probability for early claim is classifying in red, and as the probability is moving towards the lower side, which is lesser claims, it is green. Similar in the risk model, we have overlaid both these probabilities to find the final probability, and on that probability we are deciding that what type of intervention we want to do. So there are stringent action for red and maroon. We have here showing the matrix, which is a sample matrix, how we figured this out. And it is not like that there are only these two model, because what happens with the ML model, that if you build, it will always give you a higher population on which you should be triggering the risk model. So in a typical setup, you will get a 30% kind of population or 20% kind of population. But if you choke or do the intervention on that big population, your sales will get stuck. It will choked up because the process will be very cumbersome. So to get a lesser percentage, at the same time, to cover all the early claims and fraud risk, we further tweak this model with the mortality assumptions which we did at the actuarial end. So we have kind of taken the A by E ratios at the different district level, state level, to further drill this 30% to 5-6% kind of thing. And that is not a less thing, because apart from the mortality assumptions, we are also taking the partner risk scores, we are taking the click stream scores, we are taking IIB information. So there, it's a model which consumes almost 5-6 other informations to bring my whole intervention down to 5-6%. So if you see how it works, basically, as the input, it takes all the customer application information, which customer basically enters at the time of login, all his demographics, all his product details, and if it's an existing customer, what kind of products he already have, what is the total sum assured. Then we ping IIB to get the all the industry information for him. We ping Experian to get all the credit line details, and other partners also, from where we get lot of information about the customer. Then basically we run the AIML algorithm, which is our gradient boosting algorithm, to predict whether this customer will do a fraud, or there are chances of getting an early claim from this customer. And then we segregate him into 5 categories, which are basically red, maroon, amber, yellow, green. So if you see, the red and maroon are having the actions on which we do additional underwriting. It can be a income check, it can be a medical check. That kind of intervention we do to make sure we are onboarding a good profile. Yeah. So if you see in terms of results, if my overall risk at the company level is 100 times, so in the red bucket, we are able to find out 15 times of higher risk, as well as in the linked policies, it is 7 times higher. And in the second bucket, which is maroon, which is having the second range of probabilities, we are able to find out 4 times and 2.5 times of risk. And if you see in the red cases, we are doing the full underwriting, where customer has to provide the one video call with the medical, a video call with the doctor, where doctor confronts him with a lot of questions about his health. And we also test the liability during this. And he also has to submit the financial document proof, which is basically your Form 16 ITR and the bank statement kind of thing.
Mr. Akash,
In
you're close to a minute for
Yeah.
your presentation.
In the maroon case, we are not asking for the financial document, but we are only doing the video call with the doctor. And once customer submitted, he is through. If the customer is have the malicious intentions, basically they do not input all these things, and they basically churn away. The last slide is having the PTLR model live report, which is basically it's roughly 1 year of data. So if you see, our interventions are very limited in the red and maroon bucket, which is 1.5, 1.3% kind of thing. And if you see in terms of issuance, it's very lesser. That is only attributed to because model is able to identify those potential fraud and early claim cases. And as soon as the red model provides a red category on those things, the medical and financial document triggered, these customers churn away. That's why the issuance rate in the upper two buckets is very low. And if you see, decline, postpone, and withdrawal and FL cancellation is very high in these cases. Over the time, we have observed that there is a 70% reduction in the cases from the customer which are having the malicious intentions of doing fraud and early claims. So this model is live since 6th of June, and we have kind of developed another version of this model, because over the year we have gained this much experience that what type of profiles are there, and we are soon rolling out the version 2 of this model. Thank you.
Thank you, Mr. Akash. Let's start with Professor Pradeep. So your question first.
So the first one is when coming up with these red and maroon buckets, do you have explanations of why they are being categorized as risky and so on, or is it you're directly taking the output from the model on the category?
Yeah, so sir, basically, whenever we run the model, from any model, we got the probability of basically your target. So where it is high, it will always be lying in the higher range, like 0.94, 0.95, and 0.96, this kind of ranges. So we basically what we do when we take the 70-30 kind of train and test data, we make.
Sorry, I just meant, does it also point to because of this document and this detail within their submission, there is some doubt. That's why it is categorized in red. Are you
uh,
able to provide that kind of explanation?
It is because of higher probability. So red basically constitute of those cases where the probability range is lying in the higher buckets. Maybe you can say point greater than zero point 0.8 to 1, and in maroon it is zero point 0.7 to zero point 0.8, that kind of thing.
Right, but I guess what I'm trying to say is if you know why it is high probability,
Mhm.
then even within those categories you can clearly rule them out even without additional processing.
Yeah.
And the other question I had was on the non-linked and linked in your last slide. What does that mean?
So non-linked is basically the policy type. Basically, in insurance, we sell two kind of policies. One is unit linked, where your returns are market linked. It is a ULIP policy, and non-linked are basically those policies which are having traditional kind of setup where every year you give me some, say, 1 lakh rupees premium every year, and from the policy end period, we start paying you with the fixed returns. We'll say that for the next, say, 11 to 20th year, you will get 1,10,000 rupees. So that is kind of thing. In ULIP, you got a market link returns because there are some funds in which we invest your money, and that's how you get the returns.
Thank you, Professor Pradeep. Professor Lakshmi. So would you be able to turn on your video? Professor Garg, you have any questions?
Okay, yeah, I can do next.
Yeah.
So I have a few questions. First thing is when you talk about your first model, which is early claim model,
Mhm.
that is kind of easy to build because you would have the data in the past that people who have claimed within the first 3 years or whatever.
Yeah,
But the second model that you talk about, the risk model or the fraud model,
yeah.
how do you get the labeled data for that model? Right? How do you know whether the customer has done a fraud or not?
Yeah. So, sir, for that also we have a label data because in the previous years we know whom we have declined the policy, whom we have not onboarded, because there is a BRE rule engine where we basically check if the customer is doing the this kind of thing. So there is already underwriting process which basically uh, do the decline and postpone on the cases when you are
Yeah,
onboarding the
but there
policy.
could be, false positives and false negatives in that, right? Some people you may know that there is a fraud, but you may still, pay the claims because maybe the amount
Yeah.
is not that much.
Yeah,
You
so
know.
sir, it is not only the one case. There is one more thing which is known as ADD. So in ADD, what we do, we trigger the risk checks at the field level. So this data is collected from the field. So suppose a customer is came into the system with the wrong age, with the malicious intentions, and when we trigger a risk check within a year or in the first and second year, it has been found that the customer is either suppressing the information, or he has provided a fake Aadhaar card, or he has did change his date of birth. So that's how we prepare the label data, and
I see.
this practice is from long time, so we have sufficient data.
Okay. Second question I have is, when your model gives you a probability value, right?
Mhm.
But, these probability values may not reflect what is the actual probability of a fraud or early claim.
Yeah.
There's a big field in machine learning called calibration
Yeah.
and calibration of the models. I don't know whether you looked into this or not.
So basically, sir, we are not directly relying on the probabilities. That's what I told, that any model can give you probability. And when we are saying the higher bucket, it was 30%. So we are also using the mortality assumptions for all the customers which are falling in red and maroon bucket. So we are further refining those cohorts from where my probability is high, as well as I am getting higher mortality rates.
I see.
Yeah.
Okay. You might want to look at the calibration literature for your model. And the last question I have
Mhm.
is you sort of it's not clear to me in terms of what was your business impact, how many customers you applied this model on, and in terms of the total rupee impact. Have you been able to quantify this?
Yeah, I will update you. So this model is basically went live in the June month, but what we did for all the last 3 year cases, we run this model to trigger the ADD, which I just told. And we have found out that in the whole year, we were able to save almost 250 CR by canceling those policies, because these policies are issued to the person who are, say, having the cancer, who are having heart disease, who are having kidney related disease. So, and in the real life, we are not onboarding the policy. So obviously the customers are churning away, and that amounts in terms of sum assured is almost 100 CR for one year policies.
I see. Okay, thank you.
Yeah.
Thank you,
I'm
Professor
nodding.
Garg. Uh, Professor De Silva, your questions.
Yeah, thanks. Sorry, my computer was acting up earlier. Thanks, Akash. A good presentation. I had two questions on the work you presented. So the first one is on model adaptability. So it feels like it's almost a binary or multiple binary classification where it's either you accept or reject. Is that correct?
Yeah, it's a binary classification problem.
Yeah, so if you find gray areas, how adaptable is the model, or maybe as future work you plan to extend it to this situation? And also, if demographics change and if risk factors change, do you have to retrain the model with new data? Have you thought about that sort of situation?
Yeah, sir. So basically, we are continuously monitoring the population, and we are kind of monitoring also population stability index as well as characteristic stability index to check if my population is stable. The model which I developed on the population, that is a different population. Currently, I'm getting different population. So is there any difference happening? And we are kind of also monitoring how much population we are getting in red and maroon bucket. That's what I just told, that we have incorporated that feedback, and we have collected this over the you can say 1 year and 3 months, and we are developing another model that is on the basis of feedback which we have received in these years.
Okay, thanks. My second question is about the actual algorithms used. So XGBoost was sufficient. You didn't progress towards any deep learning algorithms.
Yeah, so we have used gradient boosting, not the XGBoost, but gradient boosting was performing well, so we went ahead with the gradient boosting. In the current new version of model, we are trying with the artificial neural network models.
Okay, good.
Yeah,
Thanks, Akash.
thank you,
Thank you,
sir.
Professor De Silva. And Akash, thank you for your time. You closed your
Can
presentation
I can I
as
just ask one just last?
certainly, sir. There is a minute left. Yes, sir.
Okay, so Akash is still there, yeah. So my, this is a curiosity. So you said that this is model you're not onboarding certain people. I'm just wondering, how does it interact with the laws? Because by law, are you allowed to, deny insurance to somebody who, for example, may have some, illness or something of that sort?
Yeah, sir. So basically, so first of all, we are not completely blocking the policy. We are saying if you are in red, you give me the full underwriting. Whether you submit your video call with doctor, you submit the financial document. If you're able to submit, it is in line with our underwriting guidelines. We will issue the policy. But if we find that you have any issue, or customer is having any issue, then we can decline the policy. that is in line with the IRDA guidelines.
I see. Okay, thank you.
Yeah. Okay. Thank you.
Thank you, Akash. We are sharing a link in your chat box. Please do copy the link before you leave the session. And there might be some questions from the observers as well who are part of the session. You might like to take them. So please stay back for at least for maybe next 10 minutes.
Okay, sure.
Thank you. Observers, you can ask questions directly to Akash, and jurors, please enter your scores. We'll get the next set ready for you.